Hi guys, it's Miss Austin, and I'm going to walk you through graphing a quadratic from Vertex form. It's always a good idea when we first start graphing a new function to understand where the points come from, and a good way to get those points is to create a t-table. When you're creating a t-table for a function, it's always a good idea to get some negative x values and some positive y values so you don't make any false assumptions. So I'm going to choose -2, -1, 0, 1, 2. Okay, now I'm just going to substitute those values right up here. So if I put a -2 in there, -2 squared makes y equal to 4. -1 squared, we've got 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. Okay, let's go plot those points. Got -2, 4. -1, 1, 0, 0, 1, 1, 2, 4. Okay, kind of looks like a V, maybe a U. It is a fluid curve, and so sometimes a little hint I do to make it look like a nice curve is I go with dotted lines first, and then I go back and connect those to make it look. And I'm not the best with this computer pen either. Okay, so there's our graph of a quadratic. Now we're learning about vertex form, which means this vertex is going to be in all different locations. And we want to come up with a way to get these other points here without having to make a t-table. So we want to pay close attention to the pattern that emerges around this vertex. Okay, so if you'll notice, wherever this vertex is, if you walk one to the right or one to the left, you go up one. Okay, that would be 1, 1. Where are these numbers coming from? Because if you square 1, what's 1 squared? 1. And the family we're working with is x squared. If you go back to the vertex and you walk over 2, 1, 2. What's 2 squared? 4. That's how you know. You go 1, 2, walk up 4. 1, 2, 3, 4. Same the other way. 1, 2, 1, 2, 3, 4. Okay? And this will make more sense once this vertex is not centered at 0, 0. Okay, let's go ahead and plot actually one more point with this pattern without using the t-table. I'm going to get rid of this arrow here. So imagine this vertex and you walk out 3. What's the family we're working with? We're working with x squared. So what's 3 squared? 9. So I'm going to go up to 9. And then I'm going to do the same on the other side. If I walk 3 to the left from the vertex, 3, I'm going to be up here at 9. Now I have an even more accurate graph. Oh, Miss Austin, you can do better than that, can't you? Let's try to make that a nicer line. 9. This is why the dotted works better for me. 9. Okay, a little bit better. Okay, so that is your parent function y equals x squared with a vertex at 0, 0. To graph other quadratics in vertex form, we're going to use this little strategy. We're going to find the vertex, and then we're going to use that pattern that I just talked about. So what's this pattern? The pattern is wherever the vertex is, you are going to walk 1 to the left and right, and then you will either go up or down 1, depending if it's negative or positive in front of x. What was the next pattern? You're going to walk left and right 2. What's 2 squared? 4. You're going to go up or down 4, depending if there's a negative or not. And we'll just do one more. If I walk to the left or right 3, I'm going to walk up or down 9. Okay, so 1, 1, 2, 4, 3, 9. Where are these numbers coming from? I'm squaring them. I'm squaring the first number. 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, let's go ahead and jump into some examples. So notice our steps. First, find the vertex. So from the previous notes, we know that this means this has been shifted 5 to the left and down 4. So my vertex is -5, 4. Let's go plot that. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now, some people like to put the axis of symmetry in next. Some people like to find the points next. I'll actually plot the points first here, and then maybe on the next one, I'll put the axis of symmetry in. Okay, so we found our vertex. Now we're going to do this pattern. Wherever the vertex is, well, I just found it. I'm now going to do this pattern. The pattern says walk 1 to the left and right and go up or down 1. Well, how do I know if I should go up or down? Well, you look in front here. This is positive. I mean, since there's nothing there, we know it's positive. It's not negative. So I'm going to go to the vertex and I'm going to walk over 1, go up 1. Walk to the left 1, go up 1. 1, 1. Go back to the vertex. What's the next pattern? Walk over 2. What's 2 squared? 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. That is enough right there, those 5 points. That's enough to make a nice graph, but I'm just going to do the next one just because it's easy and it'll make my graph even more accurate. So the next pattern, if I go back to the vertex, would be 3. 1, 2, 3. What's 3 squared? 9. So I go 4, 5, 6, 7, 8, 9. This extra point I'm putting in is not required, but okay. You see how easy that was to graph? And all I had to do is figure out where this vertex was and then apply my pattern. 1, 1, 2, 4, 3, 9. Same to the other side. 1, 1, 2, 4, 3, 9. Okay. Axis of symmetry is that line that cuts our parabola, the name of the quadratic, right in half. And we always have to write this as the equation of a line, which is x equals -5. Hopefully you're starting to notice it's always the x coordinate of the vertex. The domain of all quadratics is all reals. You can also write that -infinity to +infinity in interval notation. My range is my lowest to my highest. Well, the lowest the graph ever gets is right here at -4. So I'm -4, and that these arrows up on the top mean that it's going to +infinity. There is no max, and remember on infinity you have to use a soft. You could also write that as an inequality. You could put a y in the middle. I'll just also write it like this. You could also just say y is greater than or equal to -4, which implies that you're going to infinity. Okay, any of those are acceptable. You do not have to write all 3 ways. All right, let's try another one. Steps. First find your vertex and then apply the pattern. All right, this time, based on the numbers, it says -1. That means it's been shifted 1 to the right and up 7. So I've got 1, 7 for my vertex. This time I'm going to go ahead and put the axis of symmetry in first. I'm still going to do my pattern, but some people think this is helpful. My axis of symmetry is going to go straight through that vertex. You can put it in right now. I know it's x equals 1. Okay, now where am I going to get the rest of my points? Well, I'm going to use the pattern. But I do need to be careful because look, this time it's negative. So from the vertex, when I walk over to the right, I'm not going to go up, I'm going to go down. Okay, so what's the pattern? If you walk over 1, what's 1 squared? 1. That's why I went 1, down 1. And then if you already have the axis of symmetry drawn in, you can just copy that point to the other side. You can also just do the pattern over there. All right, let's go back to the vertex. Next one, walk over 2. 1, 2, what's 2 squared? 1, 2, 3, 4. You could copy that right there. That is enough points. I'm going to go ahead and do that third one just to make it even more accurate. So I'm going to go back to the vertex. I'm going to walk over 3. 1, 2, 3. 3 squared is 9. That's 7, 8, 9. There we go. Now all I've got to do is draw in my curve. All right, domain, all reals. Range, you always have to write it from lowest to highest. This time, it is headed down to negative infinity. So there is no minimum. So negative infinity is the lowest, or where it's approaching, all the way up to what's the highest it ever gets, that number 7. And you could write that as an inequality, or just y is less than 7. All right, guys, I hope that helped. I would go practice these graphs and see if it makes sense. And if it doesn't, make sure you attend your drop-in Zoom session this week. See you soon.